Hello guys, welcome back. So we have the particle set it up and it flows nicely. Let's talk about some of the attributes we can tweak. One of the things I think is important here is the flip object particle separation. Now this is basically the quality of the particles. Oftentimes a value like 0.02 will be a pretty high quality, and a value below that will go really slow, and even 0.02 on my computer, which is Core i7, 64 gigabytes of RAM and GTX 1080, it's gonna be slow, right? So just be aware that the lower this number is, the more particle it will emit. It doesn't mean it's emitting more water. The volume of the water are the same. It's basically filling in more particles inside of the same volume, and it's basically making the particle closer to each other to represent again the same amount of liquid, and because you have more particles, you're getting more detail. Alright, so again, as you can see, the render time is, the simulation is really slow now, right? But as you can also see that the quality of the shape of the liquid is getting much more detailed than before. Now I don't really need to have a lot of frames to render. I guess all I need is 120 for now. 120 should be good. I'm also gonna just go change the animation settings and change the end to also 120 and apply. So that way it's just gonna be 120 frames. Anyway, so that's one of the attributes you can tweak. But for others, I'm gonna change it back to 0.1 just for the performance is shown here. So I'm gonna go for 0.1 for now and show you something else so we can preview it better. Underneath the physical things, right, you can change this viscosity here to like 100, and also go back to the flip solver underneath the volume motion here, also turn on the viscosity. That's gonna allow the water to become stiff. Now both of those things must be on to make this work. As you can see now, the fluid are flowing more like some sort of like really stiff liquid, almost like lava, or things like that, that is not quite smooth, and so that you can see they're basically flowing like that. So for things like that, you can of course try this. I don't really want that, so I can turn that off and change that value back to 0. Again, this viscosity on the fluid object should have value, and also on the flip solver you should turn that on if you really wanted to have that effect. Okay, here underneath the flip object, another thing you can try to do is going to be underneath the bounce here. You can make them really bouncy. Now that's something that is pretty generic, so I don't think I need to explain it. So it's going to be bouncier. As you can see, the bounce up really crazy here. So I don't think I even have to mention these. You should know what they mean. So so if you want to have some really strong splashy result, you can use a high bouncy. A value of from 1 to 10, I think it's enough. Oftentimes I was doing 100 just to show you that it's show you the effect, but yeah, you can go lower than that. Okay, right, now underneath the solver, there's another thing you can do, which is underneath the velocity volume motion here, you can change the velocity smoothness to something higher, like let me do 1,000 just to see the effect. This will smooth out the water and make their motion more close to each other. So now you can see we're not having a lot of detail anymore. it's basically evening out the water fluid. So if you wanted to make them just go really smooth, you can use that attribute. Okay, so let me go back to point 1. If you don't know the default settings, you can right click and revert to default. Alright. And underneath the particle motion here, you can also go check this receding. Now I don't really think it is necessary to mention because the default setting is pretty good, but basically what this does is filling in the spaces that you think are really not having enough particle to mesh a nice geometry out of it. So let's say particle per voxel, if you change that back to I guess 1 to 1, it's gonna actually fitting in lesser particles. As you can see now, right, we're having lesser particles. Now what this does is basically trying to make have a goal for every voxel. The goal is making at least 8 particles. Now some of the settings down here is controlling, like for example this burst threshold will be controlling like the there's some mathematical thing happening, which is it will be added to the voxel once the current number drops below the product of this parameter and the goal number, which is this guy. The product from with that and that, if that and that, those two values, their product is you know, getting too low, right? It will start to fitting in, like just generating in new particles. So let's say I want more particles. You can go for a higher value here, like let's try 20 just to see it. And as you can see, we're basically having more particles because it's trying to fit in more particles per pixel. Okay, and the surface of sampling is trying to figure out the actual surface of, let's take a look, within our sampling bandwidth of the surface. Okay, so the surface of the surface, the liquid. Okay, so oftentimes I don't change these guys. I think the default settings are good. I mean, why not? Why do they change make the default setting not the best option anyways? So yeah, if you want more particles to, you know, really mesh out a solid geometry, a rich and fat geometry, you can crank that value up. 8 is generally good again, but maybe I can make it to be change it to 12 so that I'm having just a little bit more particle to, you know, work with. Alright, separation is something you probably don't want to turn on. I don't know why it does have that, but if you turn it on, the particle will just be very even out and trying to push the particles away. I guess because of some of the calculation limitations, they are the particle, actually the liquid volume will get smaller due to the squeezing between particles. As you can see now, if you turn on particle separation, it basically pushes particles away from each other and giving this very even separated results. I don't think it's really that useful. Droplets will detect the particles and see if the particles around them are less than a certain number here. If it's lesser than that, it will be considered as a droplet, which will not be contributing to the velocity field of the main body of the liquid, and they just flow away all by themselves. Again, don't really need that. And we have the vorticity thing here. Again, that's gonna be on the particle level. You can turn on the vorticity, and we have the volume level too. Basically, volume level I think is pretty good. And rest is the rest attribute. If you wanted to add rest attribute to give the particles some unique colors based on their original position or things like that. So not quite important to me either because I'm gonna render a mesh out of it anyways. All right, so here underneath the source volume, you can change something like the velocity. You can add velocity and give them some variation to start with. I think those are pretty generic on other sourcing or other import nodes. So I don't think those are needed to be explained. Okay, on the Flip solver you have a lot of other things like substeps, right? And if you wanted to simulate more G10 frames, you can do that. Particle motion. Here you have a lot of things. I think I just mentioned all these guys here again. And volume motion is basically the velocity field. You have also velocity field. If you wanted to change the velocity scale to something lower so that they're not moving as fast, you can do that too. Velocity transfer, this splashy kernel is for water that is normal and like splashy kind of thing. If you wanted to do things more like lava, you can change the transfer to swirly kernel. The swirly kernel is more clean and smooth. It's basically concentrating more on the swirly results from the liquid, not splashy. Okay, distribution is for rendering on other computers. Unless you have a big render farm or things like that, and probably don't have any option down there too. Okay. Divergency will try to push the particles into different branches. Again, don't really want it to do that either. Surface tension, I think it's going to be trying to maintain the surface volume again, so don't really need to do that either. Solver here, again, the feedback scale should be on if you wanted to push something else. I'm going to turn that back to 0. So I think those are I think at least some of the things are worth mentioning. Some of the things are really useless. I would go for default setting most of the times, unless I see something that I don't like. Maybe I can tweak some of the attributes. If you're really curious on what's actually happening, you can read the documentation here. It's a very long documentation, so you have to calm down and really read through it. Again, a lot of things rambling around, like what this does and what this does, doesn't really help too much, I guess. Some good example if they can provide would be nice, but this is like super long and boring plain text. Anyway, alright. So we have this setup for Fliud, and I just mentioned some of the quality settings, right? Let's go ahead and actually try to do something with it. I'm gonna go for particle separation again, 0.02, just to get a super high quality. And I'm gonna go back to the upper level. I'm gonna create a geometry object. I'm gonna call this guy water stem import. This is gonna be used to import my simulation results and cache it. So I'm gonna delete this file and create a .io. And .io, I'm gonna go to the network and define the network as the water simulation. The node will be our flipped object in the presets. I'm going to change that to flip fluid. Okay, that's going to allow it to export 3 basically primary attributes: the geometry itself, the surface field, and the velocity field. Okay, surface field is a stand distance field, which basically contains the information of the positive values as a distance from the surface outside, and negative value is inside, and the distance to from the surface. Velocity is velocity field, of course, and where you want to save it can be defined here. So I'm going to say maybe job right here. I have a project folder already, right? It's easier to go for job. And then the name of this file, I don't really need that. Probably just name it as the operator string here, which is this guy. So water simulation cache. Okay. And underneath save to file, you can then tell it the same frame range, and you can just click on the save to disk, and it's gonna enable the rendering. actually this convert timeline layer is going to go through the simulation again, and when it's done, you can then check on load from disk to load it. Okay, I'm going to wait for it to finish, and then we can come back in the next tutorial. We're going to go ahead and really mesh it and talk about some rendering options. Okay, see you next time.